These are the 4-4 notes. You should have your textbook open to page 237. You're going to need a ruler, highlighter, and at least 3 different colored pens or pencils today. We have a little bit of graphing. We're going to be talking about parallel lines and perpendicular lines. We're going to start with parallel lines. And in the past, we've talked about parallel lines as lines that are like railroad tracks that never touch. We're going to learn a new meaning today. And it's the same concept. We're just going to start talking about it in terms of algebra. So again, parallel lines are lines that never touch, but if we're looking at their graph and we're really deciding what does parallel mean, we're going to find out that they are lines that never touch and they have the same slope. So let's go ahead and we'll write down our old definition. Lines that never touch, or lines with the same slope. Basically what that means is if I were to have a graph and I had this line and this line, just looking at them we would decide these guys are parallel. If we keep going on either side of them, they're never going to touch. But what you can see is as this one rises this much, this one runs, and same thing here. They have the same rise and the same run. And that's hard to see because we don't have any numbers on our graph, so it's really hard to say, yes, for sure these are parallel, but we're going to assume for today that these are parallel, so they have the same rise and the same run. Vertical lines, remember, they don't have a slope. We talked about that in the previous 2 sections, but vertical lines are parallel. That makes sense. If I have a line that goes like this, it's straight up and down, and I have another line that's straight up and down. It doesn't matter how far you go, they're going to never touch, so they are parallel. However, when we're talking about them in terms of slope, we won't be able to because vertical lines don't have a slope. You can write an equation of a line parallel to a given line if you know a point that the other line and the equation of the line and the equation of the given line by 1, find the slope of the given line, 2, substitute the point provided and the slope from the given line into the point slope form. That was a lot of mixed words that probably didn't mean a whole lot. Basically what that's saying is if I have a line like this and I have a point like this and I know the slope of this line and I know the ordered pair of this line, they're saying I can write the line or the equation of the line that goes through that point that is parallel to this line using this and this. And that should make somewhat sense because we learned last chapter that if we have a slope and a point, we can write the equation of a line in slope-intercept form by plugging in what we know. We know an x and a y value and we know a slope, and we can solve for b using those things and then rewrite the general equation of the line. So what they're saying is you might know just one ordered pair and not know the slope of this line, but you might know the slope of a line parallel to it, so you can use that same slope with this ordered pair to find the equation. You know you can use this slope because up here we said parallel lines have the same slope. So we're going to try an example. It asks us to write an equation in slope-intercept form for the line passing through -3, 5 and parallel to the line y equals 2x minus 4. Now, I just need to know the slope from this second line. Remember, that's all I needed up here. Then I have an xy value of -3, 5. So now I have my slope and my xy. I want you to look at your 4, 3, 4, 2 notes and see if you can find what I'm talking about, where we had to find the new slope-intercept in order to write slope-intercept form when we just knew the slope and an ordered pair. So let's go ahead and get started. We know that slope-intercept form is y equals mx plus b. I know an x and a y, and I know my m. I don't know my b yet, though. So I'm going to plug these in. I'm going to say 5 equals 2 times -3 plus b. 5 is the y value, -3 is the x value, 2 is my slope. I'm going to start solving. 5 equals -6 plus b. Now to solve for b, I have to add the 6. I'm adding it because it's negative. And I get 11 equals b. So the new equation is going to use b equals 11 and m equals 2. In general, the equation for this line is y equals 2x plus 11. And that is in slope-intercept form, so I'm finished. Turn to the next page. We're also on the next page in your textbooks. So perpendicular lines are lines that intersect at right angles, and when we talk about right angles in previous years, we know that they form 90-degree angles. So perpendicular lines are lines that intersect at right or 90-degree angles. So they're kind of, in a way, complete opposites of parallel lines. So that's going to make sense in a little bit. Right angles are 90-degree angles. And when you're talking about lines, if you have one 90-degree angle, then you have all angles 90 degrees, because this one would also be 90 degrees, so would this one, and so would this one. So slopes for parallel lines were the exact same. When we start talking about perpendicular lines, you're going to find that the slopes of perpendicular lines are opposite reciprocals. And opposite in math means numbers with the same absolute value but different signs. Basically what that means is if I have -1, its opposite is +1. If I have -6, its opposite is +6. So just like I was saying before, the absolute value of -6 is 6. The absolute value of +6 is 6. The only difference here is they have different signs. So opposites are -6 and 6, -3 and 3, -2 and 2. The only number that does not have an opposite is horizontal lines or a slope of 0. So reciprocals are, how do we want to write this? We're going to say a fraction flipped. So if I have 1/4, its reciprocal is 4/1, or just 4. If I have 6, I'm going to rewrite it as 6/1, and then its reciprocal is 1/6. So if I have a slope of +4, I'm going to rewrite it as 4/1, and then its opposite reciprocal is -1/4. I know it's opposite because it's negative, and I switched from a positive to a negative, and it's a reciprocal because the fraction is just flipped upside down, and I have 1 on top and 4 in the denominator. So, if you're ever wondering if you made the right choice with your opposite reciprocal, you can actually multiply them together. Let's see what we get. We have -4/4, which is just -1. If you get -1 when you multiply those two together, you've done something right. If you don't, then you made a mistake somewhere and you need to go back. Vertical lines and horizontal lines are perpendicular. We can't do this test for vertical lines and horizontal lines because vertical lines don't have a slope, and horizontal lines have a slope of 0, so you'd never get -1 when you're multiplying by 0. Turn to the next page. It asks me to determine if the following lines are parallel or perpendicular or neither. So let's start with y equals 5. Remember that if you just have a variable alone, you make a t-chart. You start with x and y. And this one tells me that y equals 5. So it doesn't matter what I choose for my x value. So I'm going to choose 1, 2, and 3. It doesn't matter. Y will always just equal 5. Now, for my next one, I have x equals 3. Same thing. I have to make a t-chart, x and y. But this one says, it doesn't matter what I choose for y, x is always going to equal 3. Now, this last equation looks a little different. Again, we can just make a t-chart. But this one I have to choose kind of carefully. I'm going to choose 1, 2, and 3 for my x values, and then I'm going to plug them in. I'm going to say y equals negative 2 times 1. I got this from this column, plus 1. Now negative 2 times 1 is negative 1, is negative 2, sorry. Plus 1 gives me negative 1. Now my next one is y equals negative 2 times 2 plus 1. Negative 2 times 2 is negative 4, plus 1 gives me negative 3. My last one is negative 2 times 3 plus 1. So I get negative 6 plus 1, which is negative 5. So let's go ahead and start graphing. I'm going to start with my y equals 5. So I'm using a blue pen for that one. I'm at 1, 5, 2, 5, and 3, 5. Now, I'm going to write the equation of the line on this one so that I can keep track because I'm graphing more than one on the graph. I'm going to do x equals 3 next. I'm going to use a pink pen. So I'm at 3, 1, 3, 2, and 3, 3. Go ahead and draw on your line. Okay. Again, I'm going to write the equation of the line next to it so I can keep track of them all. Now the last one, y equals negative 2x plus 1, I'm going to use my green pen. So I'm at 1, negative 1, 2, negative 3, 3, negative 5. And then I'm going to go ahead and write in the equation of my line to keep track of them. So, if I'm looking at this, I'm going to analyze each set of lines together. If I'm just looking at x equals 3 and y equals 5, I can see they cross at a 90-degree angle. These two are perpendicular. Good. Now if I'm looking at y equals 5 and y equals negative 2x plus 1, they do intersect, but they don't cross at a 90-degree angle. So they're not parallel because they intersect, and they're not perpendicular because it's not at a 90-degree angle when they do intersect. So these two are neither. Now the last ones to consider are my x equals 3 and my y equals negative 2x plus 1. Again, these do intersect, but it's not at a 90-degree angle, so they are neither. Okay, I want you to go ahead, pause the video, try this last example by yourself, or well, I guess there's one more in the back that we'll do together. Try this example by yourself, and when you're ready, come back to the video, but you should pause because I'm not going to give any time on here. So I'm going to start graphing the first equation where I have 6x minus 2y equals negative 2. Now this one's kind of tricky. I don't have it in slope-intercept form. It's not in standard form. So I'm going to solve it to be in slope-intercept form first before I start graphing. It's easier that way. We learned about this in the last 2 lessons. So remember that slope-intercept form is y equals mx plus b. And if I do that, I'm going to move the 6x to the other side. So now I'm left with negative 2y equals negative 6x minus 2. It's negative 2y because it's being subtracted up here. It's already negative. And I put the negative 6x out front because remember mx becomes before b on the equation. Now I'm going to divide by negative 2 to get the y by itself. And I'm left with y equals positive 3x plus 1. So I'm going to make a table for this. I'm going to say x, y, and I'm going to go with negative 2, negative 1, and 0 for my points. Now negative 2 times, let's start over. Y equals 3 times negative 2 plus 1. This gives me negative 6 plus 1, which is negative 5. The second one is y equals 3 times negative 1 plus 1. This gives me negative 3 plus 1 gives me negative 2. Now I have y equals 3 times 0 plus 1, which is just 0 plus 1 or 1. So let's start graphing. I have negative 2, negative 5. -1, -2, and 0, 1. So now I have my 3 points. Go ahead and draw your line through those points. Write in the equation of the line. This is going to be y. Actually, let's write it as the original equation. So 6x minus 2y equals -2. Okay, let's graph the next one. I'm going to do green for this one. I did blue for the top one. So I have y equals 3x minus 4. Now this one's already in slope-intercept form, so I just have to start with my table. I'm going to say y, and I'm going to choose, let's see, 1, 2, and 3 for this one. Y equals 3 times 1 minus 4. 3 minus 4 is -1. Y equals 3 times 2 minus 4. 6 minus 4 gives me 2. Y equals 3 times 3 minus 4. 9 minus 4 is 5. So let's graph. I'm at 1, -1, 2, +2, and 3, +5. Okay, go ahead and write in the equation of the line for this. It's y equals 3x minus 4. Now, we're going to graph that last line, but I think we should just pause to take a look at these two lines. You can tell that it doesn't matter how far I keep going up on these graphs or down on these graphs, these lines are never going to intersect. They're parallel. Now, that should make sense because if we go back and we look at the line after we had solved it into slope-intercept form, and we compare it to the second equation, they have the same slope, but they both have a slope of 3, they just have different y-intercepts. So because their slope is the same, we should know automatically these two lines are parallel. Okay, now let's graph that last line. I'm going to do it in red, or sorry, that's red. So I have y equals 4, make an xy table. Now remember, it says y equals 4, that means it doesn't matter what I choose for my x values. So I'm going to go with 1, 2, 3, and I have 4, 4, and 4. So I'm going to start graphing. 1, 4, 2, 4, and 3, 4. And write in the equation of the line, y equals 4. We can see, yes, it does intersect both of these lines, but it does not intersect them at a 90-degree angle, so it is neither with both of them. Now, that should make sense because if it's not neither with the first line, it can't be, or if it's not parallel or perpendicular with the first line, it can't be either of those things with the second one because they're parallel. So it has to be neither with the second one as well. Alright, turn to the last page. It says that you can write the equation of a line perpendicular to a given line if you know the point of the line and the equation of the given line. Now, again, this is just like that example on the first page where we're talking about parallel lines. We know that if we're given a slope, that something perpendicular to it has to have an opposite reciprocal slope. And now we have an xy value with its ordered pair, so we can solve very similar to the first example. We're going to give it a try. It tells us, write an equation in slope-intercept form for the line that passes through -4, 6, there's our xy value, and is perpendicular to the line 2x plus 3y equals 12. First things first, this equation is not in slope-intercept form, so I need to rewrite it. So I'm going to take 2x plus 3y equals 12, and I'm going to write it to look like this, y equals mx plus b, slope-intercept form. To do that, I need to get the y's alone, so I'm going to subtract 2x. I get positive 3y equals negative 2x plus 12. Now, I want to get y alone. Divide each term by 3. I get y equals negative 2/3 x plus 4. So now, I want to write an equation that's perpendicular to this line that passes through this point. So I'm going to have to worry about this line's slope because I need an opposite reciprocal of negative 2/3 for this line's equation. So remember, I need to make it opposite, so it needs to become positive, and it needs to switch to its reciprocal. So it's going to become positive 3/2. I flipped the fraction and I made it positive. So now I have my new slope. I have an x and a y, and I know it needs to be in slope-intercept form. The only thing I'm missing is b. So I'm going to plug in those x and y values and my slope and solve for b. So I have 6 equals 3 halves times negative 4 plus b. Negative 4 and 6 are my x and y values. This is my slope that I found by finding the opposite reciprocal of the line perpendicular to the equation I'm trying to find. So start by multiplying. Remember that if you have a whole number, you write it over 1. So I have 6 equals 3 times negative 4 gives me negative 12 over 2 times 1 gives me 2 plus b. So now I have 6 equals negative 6 plus b. Negative 12 divided by 2 gives me negative 6. I need to solve for b, so I'm going to add 6 to both sides. I'm adding because this was negative, and I get 12 equals b. These canceled. So now I have my slope, I have my b, and I know it has to be in y equals mx plus b form. So the last thing I have to do is just simply plug in the values that I have found. I'm going to say y equals 3 halves x plus 12. That's the final answer for that example. Those perpendicular ones can be tricky. It's hard to remember that I have to find my opposite reciprocal first, then find b. Make sure when you're doing your homework that you are looking at that example and following it with the instructions so that it's not as difficult. Remember that you can send me an email with any questions that you have. Otherwise, I will see you tomorrow in class. Have a good night.